Assalamu alaikum. This is Rizwana Mukhtar, lecturer, Department of Physics, Milestone College. How are you all? I hope you all are well. At this pandemic situation, as you are not able to go outside from house, so I am here to take an online revision class. Today I am going to discuss about work, power and energy, which is your chapter 4. Today I am going to discuss about chapter 4, which is work, power and energy. Our first topic is work. Work, this word is really familiar with us. In our day-to-day life, we know to do something is called work. But in physics, doing anything is not work. If you apply the force on an object and displacement happen, then you can say that work is done. So what is work? Work means, suppose it's an object, and if you apply force, then if the object displaced from its position, then we can say that work is done, and work is measured by the product of applying force and the displacement occurred for this force. Work is denoted by W, and so that W equals to F S. Applied force and the displacement happen for this force. The unit of work is joule, and the dimension is m L square T inverse 2. Is of two types, positive work and negative work. If we apply the force and work done towards the force, that means in the direction we applying the force, if the displacement happen on the same direction, then we can say that positive work is done. But if we apply force and displacement happen against the direction of applying force, then we can say that negative work is done. Suppose you throw anything on the upward direction, that means here negative work is done because the work is done against the gravitational force, or the displacement is happening due to against the gravitational force. So this is the negative work. Now energy. Energy means ability of doing work is called energy. We can see there are various forms of energy in our surroundings, such as light energy, sound energy, but most common form of energy is mechanical energy. And mechanical energy is of two types, potential energy and kinetic energy. So what is potential energy? Potential energy means the capability of doing work of an object for the change of its position or its configuration is called potential energy. Suppose you take an object from ground, at 8 meter height, then this object will gain the capability of doing work, and this capability of doing work which an object gained due to the change of its position is known as its potential energy, and potential energy is denoted by EP. So EP equals to m G H. Here m means mass of the object, G means acceleration due to gravity, and H height. And unit of potential energy is joule. From the equation you can see that EP equals to mgh. That means potential energy depends on the mass of the object and height of the object, not acceleration due to gravity, because G is a constant value. So EP always depends on the mass and height. Now kinetic energy. If an object gains capability of doing work for its motion is called kinetic energy. Suppose an object of mass m kg starts to move with v velocity. So for this velocity, it will gain a capability of doing work, which is known as its kinetic energy, and kinetic energy is denoted by Ek. Ek equals to half m v square. Here you can see that kinetic energy depends on mass and velocity. The more the velocity of an object, the more the kinetic energy of that object. And the unit of kinetic energy is also joule. Now, power. Power means work done in unit time is called power. Power is denoted by P. So, P equals to W by T. And you know that W equals to Fs. So we can write this equation F S by T. Suppose work is done or force is applied on the horizontal side. That means a force is applied in this way. So we can say that F equals to ma. From Newton's second law, you know that. So we can write down that ma is by T. But if the force applied on the upper position, that means in that way, so that equation will be F equals to mg. So instead of mas, we can use mgh by T. So here you can see that there's 4 formula for power, and power depends on the mass, height and time. That means among 2 persons who are doing the same amount of work, the person who done the work in the less time will be more powerful. And the unit of power is watt, and dimension m L square T inverse 3. Now let's enjoy a video on power.
The one on the right's lifting his weight faster, but they're both doing the same amount of work. The reason I can say that is because work is the amount of energy that's transferred. Or to put it a simpler way, this is the way I like to think about it. Work is equal to the amount of energy you give something or take away from something. Both weightlifters are giving their weights the same amount of gravitational potential energy. They both lift them 2 meters and the masses are 100 kilograms each. Plug those into the formula for gravitational potential energy and you find that the work done by each weightlifter is 1,960 joules. But the weightlifter on the right is lifting his weight faster, and there should be a way to distinguish between what he's doing and what the other slower weightlifter's doing. We can distinguish their actions in physics by talking about power. Power measures the rate at which someone, like these weightlifters, or something like an automobile engine, does work. To be specific, power is defined as the work done divided by the time that it took to do that work. We already said that both weightlifters are doing 1,960 joules of work. The weightlifter on the right takes 1 second to lift his weights, and the weightlifter on the left takes 3 seconds to lift his weights. If we plug those times into the definition of power, we'll find that the power output of the weightlifter on the right during his lift is 1,960 joules per second, and the power output of the weightlifter on the left during his lift is 653 joules per second. A joule per second is named a watt, after the Scottish engineer James Watt, and the watt is abbreviated with a capital W. Alright, let's look at another example. Let's say a 1,000 kilogram car starts from rest and takes 2 seconds to reach a speed of 5 meters per second. We can find the power output by the engine by taking the work done on the car divided by the time it took to do that work. To find the work done on the car, we just need to figure out how much energy was given to the car. In this case, the car was given kinetic energy, and it took 2 seconds to give it that kinetic energy. If we plug in the values for the mass and the speed, we find that the engine had a power output of 6,250 watts.
Now last topic is efficiency. Efficiency means how much given energy we obtained as a effective energy is called efficiency. Efficiency is the ratio of input energy and effective energy. Efficiency is denoted by eta. Here eta equals to effective energy by total input energy, and efficiency always denoted as a percentage. Here instead of effective energy we can write that output energy and E in into 100%, and output energy means mgh by E input into 100%. Sometimes efficiency also denoted as the ratio of input power and output power. Sometimes efficiency is also denoted as the ratio of output power and input power. In that case, the formula will be eta equals to P output by P input. Output means effective power. So instead of P output, we can write down that P mgh by T divided by P in into 100%. From the equation you can say that efficiency has no unit because it's a ratio of same type of quantities. That means efficiency is the ratio of either energy or the ratio of output and input power. That's why efficiency has no unit, and always remember that 100% because we cannot get the same amount of energy which we given in any engine. So the efficiency of an engine never be 100%. Now I am going to solve a creative question. Here you can see that an object of mass 5 kg is kept at a position A. Here they give the total height is 60 meter. AB equals to 1 by 4 AC. Now question number C. If the time to lift the body at position A from the ground be 2 minutes, what power is used? So here's the given informations are here. Our first information is it takes 2 minutes to lift, that means time T equals to 2 minutes, that means 2 into 60, 120 second. Now the object to take from the ground, that means the height is 60 meter. Height h equals to 60 meter, and mass of that object is m equals to 5 kg. Now we have to calculate the power, that means power P equals to what? Now we know that We know that P equals to mgh by T. Now put the value of m is 5, g, you know that the value of g is 9.8 meter per second square, and here height h equals to 60, and given time is 120 second. So by calculating it, you will get the answer is 24.5 watt. Now question number D. Whether the law of conservation of energy follow at position B and C. Explain mathematically. So before calculating the point B and C, we have to identify the distance of AB and BC. Here you can see that the total distance AC is given 60 meter, and they also gave an information that AB equals to 1 by 4 AC. So here AC equal to 60 meter and AB equals to 1 by 4 of AC, that means 1 by 4 into 60, that is 15 meter. So we can easily write that BC equals to AC minus AB, which is 60 minus 15 equals to 45 meter. So here's AB means A to B, the distance is 15 meter, and B to C, the distance is 45 meter. Now we have to calculate the total energy at point B and C. So at point B, potential energy, that means EP equals to mgh. Here mass m equals to 5 kg, g, you know that the value of g is 9.8 meter per second square, and h. Now as we are calculating the potential energy, that means the height for potential energy at point B is from the ground, that is 45 meter. So height h equals to 45 meter, that is 5 into 9.8 into 45. So after calculating it, you will get 2205 joule. Now the kinetic energy at point B. Kinetic energy, that means EK. We know that EK equals to half mv square. Firstly, we calculate the value of v square. So here v square equals to u square plus 2gh, and you know that as it's a freely falling body, that means u is 0. So 2 into 9.8 into, now height, as we are calculating the kinetic energy, that means for position B the height will be 15 meter. So after E square equals to 294 meter per second. Now I am putting the value of m and v square here. The value of m is 5 kg and v square equals to 294. So that we will get the value is 735 joule. Now we have to find out the total energy at point. Total energy at point B is equals to potential energy plus kinetic energy. Here's the potential energy is 2205 and kinetic energy is 735 joule. So after adding these two values, we will get 2940 joule. Now at point C, at point C, here's potential energy EP equals to mgh. Here you can see that object is touched the ground. That means there is no height from the ground. So here's the value of h will be 0. So we will get that potential energy at C point is 0. Now kinetic energy, that means EK. EK equals to half m v square. So the v square will be v square equals to u square plus 2gh. As it's the falling body, that means u is 0, g means 9.8, and a height. You can see that object is touching the ground. That means the total height is 16 meter. So after calculating it, we will get the value of v square is 1176 meter per second. So now I am going to put the value of m, which is 5, and the value of v square is 1176. Now we will get 2940 joule. So total energy at C is EP plus EK equals to 0 plus 2940 or 2940 joule. So here you can see that the total energy at point B is 2940 and the total energy at point C is also 2940. So we can say that this object is follow the law of conservation of energy.